What's the matter, Don? Lose something?
Just myself, Tech. There's something wrong with the controls on this job, and Joe asked me to see if I could spot the trouble. I don't know where to begin. Did you ever try and figure out which does what under there while lying on your back, Tech?
That's no way to study air conditioning, Don. It's much easier to learn how the air conditioning controls work when you have the hardware out of the car where you can see it.
Well, that's just what I've got in mind, Tech. I've collected all the hardware we'll need to show Don how everything works. Now, if you'll just step this way. Fresh air enters the cowl and flows to the air door housing. When the air door is open to fresh air flow and closed to inside air, the blower delivers fresh air to the car interior. This is the air door position for the heat, defrost, and AC buttons. When the air door is closed to fresh air flow and open to the car interior, the system operates on recirculated air. This is the air door position for the max AC and the off button. The air door actuator rod is connected directly to the hinged air door. When vacuum is applied to the pot side of the actuator, the door is closed to recirculation or inside air and open to outside or fresh air. Vacuum to the rod side of the door shuts off fresh air and the system is open to inside air. There's one little detail on the air door you ought to know about. An over-center spring helps close the air door and keeps it tightly closed in either the fresh or recirculating air position. Now, if the door flutters or operation is sluggish, make sure the over-center spring is in place.
How in heck do you get at it?
Remove the glove box and you can watch the action. Check the vacuum hoses, the over-center spring, or test the vacuum actuator.
Defroster, air conditioning, and heater door operation is a bit more complicated because these doors are interconnected by a system of links and levers.
Tech's right. However, you should know how these doors work. Now, let's start with the heat and the AC doors. When the air conditioning door is closed, the heat doors are open. Notice that a spring on the left heat door shaft holds both heat doors open. Of course, it follows that the heat doors are closed when the air conditioning door is opened. Next, let's look at the AC heat actuator. This vacuum actuator is connected to a lever called the drive link. A short AC link that's part of the drive link assembly is connected to the end of the AC door shaft.
I get it. As the vacuum actuator rod moves in or out, that crescent-shaped cam slot in the lower end of the drive link turns the AC door shaft to open or close the AC door.
Right, Don. And right here, I better tell you about early production jobs with a different drive link arrangement. On those early jobs, the drive link and the AC door link are separate pieces, not a two-piece assembly like current production. Cam action between the drive link and the AC door link operates the AC door.
If the heat and AC doors don't operate properly on an early production job, the trouble may be caused by linkage misalignment or a notch in the cam face of the drive link.
Can you replace the old drive link and AC door link with a new drive link assembly?
Yes, Don. If the linkage corrections and adjustments described in the reference book don't solve the problem, you should install a new drive link assembly.
I'll remember that. What's next?
Heat door operation, Don. A nose-like projection at the lower end of the drive link pushes against a cam surface on the heat door link to close the heat door. And remember, the heat door spring opens the heat door. The defroster actuator is internally spring-loaded on the rod side. The only vacuum connection is to the pot side, so vacuum pulls the defroster link to open the defroster door. The actuator spring closes the door. The defroster door link can be adjusted to change the amount the door opens or closes. You'll find linkage adjustment instructions in recent service bulletins and in the reference book, too. Next, let's get into air bleed. This is where the adjustable bleed linkage comes in. The upper end of this linkage is attached to and is part of the defroster door link assembly. The lower end is part of the heat door link assembly. When the defrost button is pushed, the defroster door opens all the way. The slot in the lower end of the adjustable link bottoms against the pin in the heat door link, and the heat door is pushed nearly closed. This provides heat bleed to the floor. When the heat button is pushed, the upper end of the drive link provides defroster bleed. The drive link pushes the defrost door partway open against the closing pressure of the spring-loaded defroster actuator. Now here's how that works. Vacuum to the rod side of the heat AC actuator moves the upper end of the drive link so that it pushes on the defroster link to partly open the defroster door. The actuator also closes the AC door and moves the lower end of the drive link so that the heat door spring can open those doors.
If you have to adjust heat door bleed or defroster door position, here are a couple of gauges that will simplify the job. The reference book tells you how to make these handy-dandy tools and explains how all air door linkage adjustments are made. What's next, Joe?
Temperature control, Tech. Temperature is controlled by regulating the amount of water flowing through the heater core. That means that all incoming air flows through the air conditioning evaporator and then through the heater core. The temperature control system consists of a vacuum regulator at the instrument panel control unit and a vacuum-controlled water flow valve in the engine compartment. A cam contour at the inner end of the temperature control slide lever moves the vacuum regulator. In the full heat position, it delivers about 15 inches of vacuum to open the water valve. In the no heat position, the regulator reduces vacuum to 1 inch or less. To check the vacuum regulator, push the heat button, remove the vacuum line from the water valve, and connect it to a vacuum gauge. With engine running, vacuum reading should be 1 inch or less in the no heat position, 8 inches in the mid heat position, and about 15 inches in the full heat position.
How come there are 4 water hose connections at the water flow valve, and which hose connects to what?
The 2 front hoses connect to the engine and water pump. The 2 rear hoses connect to the heater core. This type water valve is a combination bypass and flow control valve. The small hose connector is for flow from the engine. The other connector on the same side of the valve connects to the pump return line. In the no heat and no vacuum position, water flow is from the engine through an internal bypass inside the valve and back to the pump inlet.
Then there's no water pressure at the other side of the valve, right?
Wrong, Don. Inside the water flow valve, there is always a direct passage between the pump return line and the heater core return line. However, in the no heat position, all flow through the heater core is blocked by the closed flow valve. This explains why you can't check to see if the valve is closed by removing one of the heater core hoses. You'll get a bath if you do, even when the valve's closed. When the temperature control lever is set for heat, the vacuum regulator supplies vacuum to open the water flow valve. Water flow is then from the engine through the heater core and then back to the pump. To test the water valve, disconnect the vacuum tube from the valve. Disconnect and plug the water hose leading from the valve to the heater core. Now that's the one directly opposite the small hose coming from the engine. Start the engine and check for water flow from the water valve. With no vacuum applied to the valve, there should be no flow. Next, make sure the temperature control slide lever is in the no heat position. Then reconnect the vacuum tube to the water valve. If water now flows from the valve, check for vacuum at the vacuum tube. If there's more than 1 inch with the temperature control lever in the no heat position, something's wrong with the vacuum regulator.
What's the advantage of this valve over an ordinary series flow valve?
Flow through this vacuum-controlled valve is much less affected by variations in water pump pressure. Now, this ensures excellent temperature control at all engine speeds.
And at this point, it's time to turn the record.
Let's tackle the time delay relay next. It's a vacuum-operated electrical switch that's connected into the compressor clutch circuit.
And what is it supposed to do?
Well, the time delay relay energizes the compressor clutch when the defrost or the heat button is pushed and outside air temperature is above 25 degrees. This dries the air and reduces likelihood of condensation on the windshield.
Sounds mighty complicated. Can you explain how it works?
Sure thing, Don. The time delay relay, or TDR switch for short, has a vacuum chamber with a diaphragm. A vacuum source is connected to the switch at one end. There's a set of electrical contacts inside the vacuum chamber. One of these contacts is fixed. The other is movable and is connected to the vacuum diaphragm. These contacts are normally closed, completing an auxiliary circuit to the compressor clutch. Two external vacuum tubes run from the vacuum source connection to the vacuum chamber at the other end of the switch. The smaller tube contains a restriction which slows down airflow from the vacuum chamber to the vacuum source. When the temperature is below 25 degrees, a thermostatic vacuum valve in the vacuum chamber is open. Vacuum opens the electrical contacts without delay. So, if it's cold outside, the compressor clutch doesn't engage when the heat or the defrost button is pushed. When the temperature is above 25 degrees, the thermostatic vacuum valve inside the vacuum chamber closes off the vacuum passage connected to the large, unrestricted vacuum tube. Under these conditions, the only vacuum applied to the vacuum chamber is through the small tube having the airflow restriction. It takes anywhere from 2 to 10 minutes to pull enough air out of the vacuum chamber to open the electrical contacts and stop the compressor. In addition, a small plastic orifice is inserted in the vacuum tube leading to the defroster actuator. This restriction slows down defroster door opening. As a result, most of the moisture in the system is discharged out of the heat ducts instead of onto the windshield.
Thanks for explaining how the TDR switch works, Joe, but now I have another question. Is this piece of insulated wire supposed to be stuck into this vacuum harness?
You bet it is, Don. And here's what it does. That piece of wire is a vacuum bleed. You might call it a planned leak that lets air bleed into the vacuum reservoir when the engine is shut off.
But why is that necessary?
If you didn't bleed the system, vacuum trapped in the TDR switch would keep the electrical contacts open. As a result, the TDR switch would not engage the compressor clutch the next time the defroster or heat button was pushed.
And the TDR switch wouldn't work, right?
Exactly, Don. Right about here, I better give you a quick rundown on the electrical connections and circuits that control the compressor clutch and the blower speeds. On the back of the push-button switch, this is the clutch circuit input terminal. The terminal above it is connected and hot when either the AC or the max AC button is pushed in. There isn't anything complicated about the clutch circuit. The push-button switch completes the circuit to the compressor clutch. Incidentally, the clutch circuit has its own fuse. These are the blower circuit terminals. This is the input terminal. The terminal at the left feeds the blower switch for heat and defrost. The remaining terminal feeds the blower switch for the AC and max AC buttons. The blower circuit includes the 3-position blower switch, the resistor block, and the blower motor. There's no point in going through the circuit for all 6 blower speeds. You can trace these speed circuits out on the wiring diagram.
6 blower speeds? How do you get 6 speeds with a 3-position switch?
When the heat or the defrost button is pushed, this terminal of the push-button switch does not feed the blower speed selector switch directly. Instead, the circuit goes through one of the resistors in the resistor block and then to the speed switch. When the AC or max AC button is pushed, this other terminal feeds the blower speed control switch directly without going through any of the resistors. In other words, for heat or defrost, there is always one more resistor in the circuit than there is for AC or max AC. That's why all three heat and defrost blower speeds are slower than the three air conditioning speeds.
Thanks, Joe. That explanation will help me understand the wiring diagram. What's next?
Well, the vacuum part of the push-button switch is next, Don. The switch is serviced as an assembly, and you can't install the vacuum tube connector wrong. When you're trying to diagnose vacuum control problems, the most helpful thing to know is which vacuum tube does what. I'll use the vacuum tube connector to identify each tube. This port is for the vacuum source. It has a green stripe and connects to the vacuum reservoir.
Isn't that the tube that has the T connector and that vacuum bleed wire you told me about earlier?
It sure is, Don. I'm glad to see you're wide awake and right on your toes. This port at the right has a short tube with a red stripe, which connects to the rod side of the AC heat door actuator. It closes the AC door and opens the heat door. The port on the left has a short tube with a white stripe. It's connected to the pot side of the AC heat door actuator. Vacuum in this line opens the AC door and closes the heat door. This next tube with a white stripe is the one that has the plastic restrictor in it to slow down the opening of the defroster door. It connects to the pot side of the defroster actuator. Now, the white striped tube from the next port has three branches. One branch goes to the vacuum regulator for the water valve. One goes to the air door actuator, and the remaining one goes to the time delay relay. Now let's trace each of these branches. The first branch goes to the vacuum regulator. From there, a larger tube with a green stripe goes to the water valve. On present production cars, there is no vacuum in this circuit when the max AC button is pushed. On very early production cars, the vacuum regulator was connected directly to the vacuum reservoir. The second branch goes to the pot side of the air door actuator. Vacuum applied to this tube with a white stripe opens the air door to fresh air and closes off recirculation. Branching off from this line, a white striped tube goes from this T connector to the time delay relay. This is the circuit that engages the compressor clutch when the defrost or heat button is pushed, so the air is cooled and dried before it hits the windshield. But let me summarize what these three branches do. Vacuum applied through this port supplies vacuum to operate the water valve, opens the air door for fresh air, and provides the vacuum to operate the time delay relay. This next port is the easiest of all to explain. It's plugged, and it isn't used with this particular air conditioning system. This last port also has a long tube with a red stripe. It goes to the rod side of the air door actuator. Vacuum in this circuit closes the air door to fresh air, opens it to recirculation.
The old thumb rule for hose colors and connections still holds true, Don. Tubes with a red stripe are connected to the rod side of the actuator. The white stripes go to the pot side. Just remember, red to rod side.
Is everything you've covered today in this month's reference book?
It sure is, Don. In addition, there's a new control function chart that tells you exactly what should happen to every door, every unit in the vacuum circuit, and every electrical unit for all 5 push-button positions. Now, this will come in mighty handy for troubleshooting control problems.
I'll read this reference book at least once and then keep it handy. I'll bet the next time I'm lying on my back looking at an air conditioner, I'll be able to figure out which does what.
I think you will, Don. I'm also sure that the information in this month's reference book will clear up a lot of questions for you master technicians out there and help you solve your control system diagnosis problems. Be sure and give it the once-over.